In this video, I'd like to talk about the math question of the day for Wednesday, June 28th, 2023. And with this problem, we need to find x, this missing side length here. And finding missing side lengths in right triangles is something that's typically seen in a geometry class. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you've attempted the problem, let's start working through this. And to find this missing side length, what we need to recognize is that this smaller triangle here is similar to this bigger triangle here. And once we show that the two triangles are similar, then we know that their side lengths are proportional. So the way to show that they're similar is to recognize that the smaller triangle and the bigger triangle share this angle A. And they also each have right angles. And when triangles share two angles in common, they always share the third angle as well. And that is something that can be proven. Now, once we demonstrate that they share three sets of equal angles, we can write that they're similar to each other. We can say that triangle ABC is similar to triangle ADE. And the order is important here. The angles have to match up. Angle A, of course, matches up in each. Angle B and D, those are the right angles. And we showed that angle C and E must be equal as well. So we have these two similar triangles. And like I mentioned, similar triangles have side lengths that are proportional to each other. Essentially, what we can show with similar triangles is that one triangle is a scaled version of the other. If we start with this smaller triangle, then we essentially multiply all the side lengths by the same number to get the bigger triangle. And likewise, if we had the bigger triangle, we could divide all the side lengths by the same number to get the smaller triangle. And we just need to figure out what that proportionality constant is. What did we multiply 4 by? We could say we multiplied by A to get x. And for this side length here, this is side length 6th. But for the side length AD, if we add these together, that's 11. So what did we multiply 6 by to get 11? And that number A that we're looking for is the same when we multiply 4 to get x and when we multiply 6 to get 11. But we can also set up proportional relationships here. We can compare the side lengths. We can say that 6, the smaller side length here, the side length AB, compared to the bigger one, AD, 6 divided by 11, this ratio here will be the exact same ratio for comparing any of the side lengths. So this would be equal to the ratio of this smaller side 4 compared to this bigger side x. And if we wanted, we could do it for the hypotenuse of each triangle. We can compare the smaller hypotenuse, AC, to the bigger one, AE. So this proportionality is true for comparing any of the side lengths. But right here, we have an equation that we can use, and we can solve for x. So let's actually work through this. We want to get x out of this denominator. So let's multiply each side of this equation by x so that on the right-hand side, it cancels out. We get x multiplied by 6 over 11. I'll write the 6 in front, and we'll divide by 11. And this is equal to 4. Now, to solve for x, we can multiply each side by 11 to cancel out this denominator. 11 divided by 11 is just 1. So we get 6x is 44. And our last step is to cancel out this multiplication. We can divide each side of this equation by 6. 6 over 6 is 1. So that we just get 1x, or x, is 44 over 6, which we can simplify to 22 over 3. So the length of this missing side here, x, is just 22 over 3, or as a mixed number, this is 7 and 1/3. So we really just need to find this missing side length here, and we did that. But we can also figure out this proportionality constant if we start at this side length 6, and we ask ourselves, what do we multiply 6 by to get 11? And you can multiply 6 by 11/6 so that you get 11. So it looks like our proportionality constant, which we called A, is 11/6. And we can see that if we take 4 and we multiply it by 11 over 6, we get that 44 over 6, which we know simplifies to 22 over 3. So from going from this smaller triangle to the bigger triangle, each of these side lengths were multiplied by 11 over 6.